Okay, so today's lesson or class is about diagrams. So diagrams are a very important part of an engineering project and a common method of communication for operation and maintenance process systems. So there are a number of types of diagrams that you need to be familiar with, and they work at different levels. So you start in a big picture, bird's eye picture, and zoom in until you get more and more detail. Now it's important that you have a common language, and this means it needs to be a standard for drawing so that anybody coming into your facility can read the diagrams and understand what they mean unambiguously. They should be clear and efficient, transferring the relevant information process. So you can assume that the reader is somebody who is an expert in the area and does understand the international standard used to make these drawings. So there are standards that come out of the USA, and there are standards that come out of Europe, and no doubt there are standards in other countries. So first type of diagram we're going to look at is a process flow diagram. And this is the big picture diagram. It helps you design the process, or if anybody coming in and trying to find out overall what the process does, they can look at the process flow diagram. And we've already looked at a form of process flow diagram when we looked at flow charts in designing ladder programs. They take a different form when we're actually designing hardware. But the key thing is they're a zoomed out picture of the overall aspect of the system. They do not contain excessive detail, and it's usually the first stage of design. So what do PDFDs contain? So they should contain a sequence of actions that are used in the making of an output. There should be indications of what are the inputs and what are the outputs, what materials or services are coming into the process, and what type of decisions are made. So as I said, we've already looked at flow diagrams, and there are standard symbols used in flow diagrams, and you've come across these before, I'm sure. So there's the decision block, input, output block, a link to other areas in the page, a process block, terminal block, and there are some outputs, data storage, and manual input. So this is the flow diagram that we used for the tank filling process. So I won't spend much time on that. As an exercise, you can go to one of the websites and have a look at some of the tools. I've shown a link here of some of the tools for making process flow diagrams. The next stage of detail is what's called a P&ID, and it's piping and instrumentation diagrams. This is a graphic representation of major piping and instrumentation, but it doesn't go into all the fine detail that you might need to actually build the process itself. It contains sort of information on control and shutdown protocols, safety and regulatory requirements, and startup and operational information. So P&IDs are often the first point of call when reviewing fault or checking on alarm situation. So it's a sort of a bigger picture, but it gives you enough detail to try and work out where the problem may exist. They're also useful in planning maintenance and restructure of processes, because they can be a recording of how things have been improved or how things can be improved. So P&IDs are used by engineers, field technicians, and process operators to clearly see how instrumentation and control are interconnected. They're also very useful for training new staff in the facility or any outside contractors that may be brought in to modify the hardware. So what should a P&ID diagram contain? So information about mechanical equipment, so usually they're numbered, given a name, all the valves and their identifications, process piping, sizes and identification, various vents, startup and flush lines, flow directions, interconnections, reference control inputs, outputs, interlocks, enunciation inputs, computer control system input, and so on. So to maintain clarity, it is best for the drawing not to contain too much information. So you don't really need to put in instrument root valves, control relays, manual switches, primary instrument tubing and valves, and so on. So what does a P&ID look like? This is a copy of one taken from text. So in this diagram, we can see a reaction vessel. We can see various lines with arrows, with some wording, some naming on each of these lines. There are some lines with dashes going across them, like this. So these obviously refer to some sort of standard to indicate what these lines are about. And given the information here, we can see that these are pressure lines, and it's a sort of a pressure control system that may be in operation in this system. We also see another set of lines, this time dashed lines, and we see 4 to 20 milliamps, so this is some sort of electrical connection. We also have some various instrumentations around, so we have a temperature monitor here, and it's given a number 301, compared to this one, where it's related to temperature, but we have a line through it, so that line must mean something related to the same system, and this one is also connected. So it seems that this is a control system, 301, somehow picks up information from the reaction vessel, and based on that controls this valve, so this is a valve, and allows steam to come in. We also have reacting out, so we have a flow meter here, and again we're taking measurements with some sort of flow instrumentation, and there's some sort of mathematical function taken on that, and then that information is then passed back to control this, this valve, and all this is connected by 302. So when there isn't a line in these instruments, that indicates that these instruments operate in the field. The operator, the remote operator, cannot see the information. Whereas in this case, there's a line going through, so this indicates, and similarly here, that indicates that the remote operator can also see this value. Okay, so the symbols that are used in these diagrams are part of an industry standard, and the industry standard defines the graphic elements you're allowed to use. So the standard defines a number of terms. I'm not going to go through all of them, but there are terms that indicate whether the area is accessible, whether there is the alarm function, whether it's behind some sort of electrical panel or some other panel, whether it's a controller of some form. There are control valves that are indicated, whether it's a distributed control system, whether you can see information on panel mounted, so you can see the information, process information, process variables, shared display, some sort of transmitter. So symbols. So symbols indicate what sort of instruments are there or what sort of controller is there. So we can have instruments that take measurements like flow and temperature. They may give out a display or they may send a signal transmitter. Computer systems are usually indicated by a hexagon. Instruments like temperature transmitters are usually indicated by a circle. And programmable logical controller, or PLCs, are usually indicated by a diamond inside a square. Now I mentioned these horizontal lines, and that sort of indicates location. So no line means the device or function is in the field. It's actually in where the process is being operated. A single horizontal line, which we did see earlier, means that the function is in a primary location category. Usually that means the operator can also see the information. A double line indicates auxiliary, and a dashed horizontal line indicates the device is located behind panel. So you note that this sort of information can tell somebody as they come in where these instruments may be found. Now, we also saw in the earlier diagram that certain letters are controllers. So there is a letter and there is a number, and this is also part of international standard. So, for example, first letter indicates what is being measured, the initiating variable, so it could be analysis or flow or temperature. Subsequent letters define what kind of readout it is, passive or output functions, whether it's an indicator or a recorder or a transmitter. And number is usually assigned to give more information about the application. So in the standard, there's clause 4.2 that indicates what letters can be used. So we'll go this fairly complex table. So we just pick on something here. So we already saw T for temperature. So the first letter is T, and then subsequent letters, we go along here, we say, BA transmit. So it's actually transmitting the signal electrically. If we pick another one, flows, so F stands for measuring flow. So succeeding letters can tell us whether it's measuring ratio of some flow. What else can we find here? The simple levels, whether it's measuring some level or something. So the first letters are a measured initiating variable, and if required, have a combination of some variable modifier we saw. So the specific meanings of each of these terms are given in the table as part of the standard. So I ask you to read this information just to be familiar with it. There are some cases where you can choose some letters for yourself and what they mean. Again, it's just a matter of working through. I'm not going to go through all this stuff, but please have a read of this stuff so that you're sort of aware of it. I'm not expecting you to remember each one of these letters and what they mean. But when you look at a P&I diagram, you should be able to know how to understand the diagram. So it's quite extensive, the standard, and detailed, and you need to keep the standard. Don't correctly mark things that could cause error, a problem, disaster, and you become responsible. Okay, it just goes on and on and on, and so just have a read of this information. Okay, so what are some typical combinations? Again, we'll take the easiest case. We say, okay, look at temperature. So we have a recording temperature. We have an indication of the temperature. We have some sort of valve that's related to the temperature. The readout devices, recording or an indicator. This one is whether we have transmitters or not, and so on. So when making your P and ID diagram, you need to refer to this standard. So in addition to the letter combinations, a succeeding number has a unique identifier of the actual instrument that's used. So as we saw earlier, you can link up a bunch of controllers and valves and instruments to indicate that that is a control loop. And when we looked at the diagram, we saw that these were these lines. So a single unbroken line with nothing else indicates an instrument supply. We saw we had a pneumatic system. So that was thing working from 3 to, say, 15 psi. So that was a pressure control system. When we have 3 lines through, or we have a dash, then that's an electrical signal. We can have hydraulic signals, electromagnetic, mechanical signals, and so on. So we need to keep to the standard of using this type of connector connecting devices. And general symbols, so we've already seen some of these. So the single circle indicating some instrument, and it will have, say, some letter inside, like temperature transmitter. And if it's got a line through it like this, we said it normally accessible by the operator. And this one with 2 lines through it indicates that of auxiliary location. Then we have other types: shared display, shared control. The hexagon indicates a computer function, and a PLC is indicated by this symbol. So then we have some ACT devices like valves and so on, and they have their symbol, which we need to stick to. So here's some more control valves, conveyors, pneumatic actuators. So this one is operated by pressure. We can see a line coming in with 2 strokes. So actually the actuation is also controlled by pressure. Here we have a motor, got a dash line coming into it. So obviously it's controlled by electrical signal. Heat exchanger, so it could be steam coming in here, steam coming out, and so on. All right, so there are a number of tools available. You can check out these websites for tools. I actually use none of these tools because I tend to use a language called LaTeX to do my drawings. But it has a pretty steep learning curve, so using one of these packages is probably useful. These websites are also some examples, so it's a good idea to have a look. So we'll have a look at a few. So I'm going to consider this diagram, and we've sort of already looked at this diagram. And again, we have the pneumatic connections, electrical connections. We have some mathematical functions. We have the flow transmitter. As we can see, these items are actually in the field. This one is available to the operator, so this is a flow recorder. And this one is a flow controller. And here we have the valve. So what is given here is a description of all the different parts, so indicating what they are. So it would be useful for you to go through and read these items and diagram. Here's another example, different type of example. So this time we have some sort of computing device. Here we have a PLC. We have a level transmitter here. It's linked up to all these other terms. So we have some way of controlling this valve. So we're measuring the flow. So there's some sort of computation that's gone in after we've measured the flow. There's some electrical connection to this valve. So the valve is controlled by electrical signal. A more complicated diagram contains more items. So I'll leave you to go through this and refer to standard and make sure you understand what each one means. So really, today's lecture is not going to be very long because most of what I need you to do is to actually go through and read the document, look at these diagrams and get yourself with them. I strongly suggest that because when you go to a job interview, it's for a process engineer, you're very likely to be given one of these diagrams, asked, okay, tell me what it does. Or you may get asked the question, what is this part of this diagram all about? And so once you do, at least once go through and get an idea of what P&I diagrams are, because they are a very common tool to use process and control. So that's it for today. It seems that a lot of people are busy with seminars, finding your seminars, so you don't have people around. So, okay, we'll leave you to go through this stuff in your own time. So this is where the lecture finishes, and hopefully we'll see you on Thursday, but it may be a similar situation. Okay, thank you.